Hi, everyone. Today we're going to be talking about solving inequalities. So first off, it's important to know that an inequality is an answer to a problem that has more than one answer. So for example, if I gave you the question of what's a number greater than 5, well, that could be 6, 7, 8, 9, 10, 11, 12, all the way up until infinity. To save yourself some time, we're going to write it as an inequality instead of writing all those numbers. So let's take a look at it. So simple inequalities can be written in these two forms. We have x, which is a variable in this case that is greater than c. And c in this case is going to be a number. You were right, or you're probably thinking they're both variables. But as we move on, what we should see is that c is equal to a number. And that's what I have right here. This sign, I'm sure you've probably heard in the past, but one of my favorites is that it is a crocodile mouth and that the crocodile mouth wants to eat the larger portion. So in this case, the X is where that mouth is heading towards. So that is why this statement is X is greater than a number. Pen's not quite showing up. There we go. And that leads us to our next statement, which has an X, and then the mouth is turned the other way, or the inequality sign is the actual term for it. And from C, remember C in this case is just a number. We don't know that number yet, but we will read this as X is less than. So again, thinking of that crocodile mouth wants to eat C. So taking a look at that X is not the bigger amount, C is, so that's why we read it as X is less than. It is very important to get these straight in your head because they are going to show up over and over and over again. Guarantee you're going to see them in the next couple of years of math. So not only do we see this as comparing numbers, but we can also see it represented on a number line. So I have my first statement of X is greater than C. We'll get into a little more detail, but this is kind of the basis of it. We would have an open circle around the number that C is. And then we would want to shade all the numbers or put an arrow towards all the numbers that are greater than that, representing that the solution or the answer to our problem is every number that is larger than C. Again, we'll get to a real world example in just a little bit, or real number example, I should say. But again, this is the general idea. So X is less than C. Again, we have an open circle around that number, and we are shading all the numbers that are less than that. So here are some directions on how to do it. First, place an open circle around the number and inequality. It's important to keep an open circle because when you get older, you're going to be adding on to the skill where you will have a closed circle or solid and dotted lines. So it does get, or the skill does add on. We're just learning the basis of it. So an open circle around the number and the inequality. Then you're going to draw an arrow or shade the numbers in the direction that answer the problem. So in this problem, we have X is greater than C. So we want to draw or put a line or shade all of the numbers that are greater. So if the number line is drawn correctly, this should be everything to the right. The opposite is for our next one, which is X is less than C. So we're going to draw everything or shade everything to the left. So all number lines in this case should be written from the least number to the greatest number. And that should be a T at the end. Sorry for that. From left to right. So here's an example, something with real numbers that hopefully would be a little clear. So X is less than 2. So that means that my variable is less than the number 2. If we think in our heads, numbers that are less than 2 are 1, 0, -1, so on and so on. That x can be practically anything, or it can be anything less than 2. So instead of writing out all those numbers, what I'm going to do is follow my directions up above by placing a circle over 2 on my number line, and then shading all the numbers to the left. Because I know that 1, 0, and -1 are just a few examples that are numbers less than 2. If you have any question on this, please let me know. Now we're going to get into a little bit more detail of combining things that we have already learned with this concept. So solving inequalities when you have to get the variable alone, that is going to be something that we're going to be practicing. So when we have to do this in an inequality, or pretty much in any operation, use the opposite operation. You have heard me say this multiple times. We've already talked about it. Just because there's an inequality sign instead of an equal sign doesn't mean that it changes. So I have 4 examples right here. Let's look at that first one. X plus 3 is less than 5. So we want to find a number that when added to 3 will be less than 5. Again, you might not be, or you might be able to do this in your head, but what we want to do is use the opposite operation to make our life so much easier, especially when the numbers start getting harder. So the opposite operation of addition is subtraction. So I have my x plus 3. I'm going to subtract my 3 from both sides of that inequality, and I'm going to get an answer of x is less than 2. I can draw my number line by putting that open circle around 2 and shading, or putting an arrow or shading towards the numbers that are less than 2. For example, 1. Let's look at that second problem. So we have x minus 4 is less than 7. We want to find that number that will make this side less than 7. So let's use the opposite operation again. So opposite operation of my subtraction is going to be addition. So I have my x minus 4. Since I'm subtracting 4, the opposite operation is adding that. If I add 4 to both sides, I'm going to get an answer of x is less than 4. So that means that any number less than 4 will make this statement true. So that could be 11, 10, 9, 8, 7, 6, 5, 4. You get the idea. So I can draw that on my number line by having an open circle and having that arrow towards the numbers that are less than 11. Moving on, next type of problem, we have 5x is greater than 15. I need to find an amount for x that will make this side greater than 15. So again, maybe you can think of it in your head, but it's great to use that opposite operation, get in that habit for when these numbers get harder. Since 5 and x are right next to each other, that means they're multiplying. The opposite of multiplying is, of course, division. So I'm going to take my 5, divide it by both numbers on either side of the inequality, and I'm going to have my answer of x is greater than 3. Again, that means that I can have a number greater than 3 that will make this true. So we have 4, 5, 6, 7, 8, 9, so on and so on. So x is greater than 3 will give us our answer. Then finally, we have our last problem, which is x divided by 2 is greater than 7. So we have a division problem. The opposite of that is multiplication. So we need to multiply. Instead of dividing by 2, we're going to multiply by 2. And 7 times 2 will give us an answer of x is greater than 14. We have that open circle again, and that arrow heading towards the numbers that are larger than that. So we have 15, 16, 17, 18, blah, 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 blah. And that will make our statement true. Any number greater than 14 will help us get a number greater than 7 once we divide by 2. One thing that I want to make sure that I got said and understood is that this open circle, this open circle on the number lines mean that we cannot include that number to make this true. So for example, our number 2. If we plugged in 2 in here, 2 plus 3 is equal to 5. 5 is not going to be, or to solve this statement, or 2 is, 2 is not going to make this statement true. We want a number that is less than what we have right here. So that's why we have that open circle. It's kind of a hint to us, telling us that 2 cannot be included. But literally any number smaller than that will make it true. Same thing with this one down here. 11, if we plugged in 11 to this equation, would not give us an answer that is smaller than 7. Instead, it's the numbers that are smaller than 11. Once we plug that in, that will get us our answer of a number smaller than 7. So that includes any number below 11. So got to keep that kind of difference in mind. Again, you're going to be adding to this in your future. If you have any questions, please let me know.